Okay.
Yeah, I was asked to give a short presentation about Active AE. So I guess you all know that I did not fight for this project, getting the owner of it. I just picked up the hot potato. Finally it got the topmost item on my shit list. And then I did look into the old engine and finally decided that there's no way to patch it, to fix it, and started a new one. Short agenda. Brief overview about the active object model I have used for the engine. The design steps about the structure, behavior, the communication, how the data flow is, and how it uses the resampling library of XBMC. And maybe we can do that interactively, so there's no Q&A afterwards, so they do that during the presentation. Well, the basic building blocks for active object is this encapsulation shell. And ideally, this shell blocks the outside view to the inside and vice versa. So there's no public members or public functions the outside world can call on the object. And even the other way around, and ideally we have no global, so all communication with the object is done via the ports. The only way of communication here. And what we are doing, we send a message in, the object does anything inside and reacts with pulse messages. Well, with Active AE I had to violate the concept a little bit because of the outside API. So the next thing was a PA player with all the polling of the is draining, is fading, is buffering, and that's really nasty. And there's a lot of improvements still which can be applied to the engine. And focus on state. So I find it very easy to focus first on state and then on the data. So we have an object, state S1, we get a trigger message from the outside, we take the state transition with the action code and respond appropriately. And I have done entire complex system with this concept. So it was fun and was very easy and very fast, and the architecture is very stable if you just rely on this concept. So the active object pattern is not new, it's no rocket science, it's field proven, and it's even inside XBMC. So it's very similar what you find with DVD player. It uses the pattern already. Maybe in a slightly different way, but it's the same pattern. Active AE implements hierarchical state machines. It can go a code snippet afterwards. It handles messages primarily based on state. So it first looks at the state of the object and then on the message itself. And Active AE uses not only one port, it uses several ports. It separates the different aspects of behavior. Often you have 30 to 50% of the code just to bring the object or the system operational, up and down, configure it. And that makes it the normal flow kind of brittle if you have that interleave. So if you can separate it, the normal flow is very easy. And sure, the error handling, we can do that as well. Perfect. So that's the structure of Active AE. We have the blue box here, the overall component with not really an encapsulation shell because we have the function-based API to the outside world. And we have an object here that's a sync driver. The old engine has only a single thread. Active AE has two. We have one active object, the engine itself, and we have the sync driver. And I think it's very easy now to plug in different kinds of things. So we already had a discussion about is it possible to plug in the core audio sync or the how's it called for Android audio track sync, yeah. And there has been discussion about push or pull models. It doesn't matter here, so you can plug any kind of thing. And I think the audio track sync already has an encapsulated thread. I think we can get rid of this thread because Active AE sync does all which is required. The communication is done via this port. We have one port for data, sending the audio buffers into the engine and through the sync, and a control port for bringing the system up and down. That's actually the state machine of the sync component. So I think looking at the modular state machine, it's very easy to understand the structure and the behavior of the component. And one reason I'm doing this is I want you look into the code and fix remaining bugs. So we have here on the left-hand side state unconfigured. When we get the configure message, we take this group transitions above, go to the idle state, and depending whether we are in silence mode or not, we go to this state, or we stay in the idle state. And we have three transitions here named sample. So depending on the state we are, we take different actions if we get a sound sample from the engine above. So if you are in idle state, we send a sample of silence first out to the receiver to wake it up. If you're in the suspend state, we have first to bring the engine or the sync online again. And if we are in any other state, we just output the sample.
Are samples passed by messages too?
Yes, but not by DevCon. We have a structure with it sent as a message, and the structure has a pointer to a buffer pool that the sound sample is stored. And in the past, I worked a lot with code generators. I used UML modeling tools which transformed this models into executable code. And this is what I've done here. I was thinking in models and the state machine, and I transformed the state machine into the executable code. And what is here in the code is big switch case statement. Maybe one important point. The switch case loop first looks on the inner state, and then it goes outside. So if we're in a state, for example, silence, and we get a message configure. It first looks, does the state silence has a trigger for configuring, and if not, it goes to the outside states. And I think it's very easy to adapt the code of the model to new requirements, so you can do bug fixing very fast, I think. And we have another building block is the port. Port is actually an instance of a protocol. And it's very similar to what we have in DVD players, the DVD message queues. And here we have a enum, we have the different signals we respond to, and one enum for the every direction. So this guy here, this is for configure, unconfigure, volume, flush, and returns, acknowledge, error, or some statistics. I have implemented synchronous and asynchronous message parsing. This is done by the protocol or the instant support. We can send out a message. See here the signal itself, the data, and it supports two different mechanisms. One is sending messages by data. In this case, it does a deep copy of the data. And the message, I think I have a payload size defined of 32 bytes or something. And if the data fits into the payload size, there's no memory gets allocated. And if it doesn't fit, it will allocate some memory in the heap and destructs afterwards. But for the sound buffers itself, they're huge. It does mainly send a message or the data by reference. In 5 or 10% of the time, we need synchronous message parsing. In this case, the sender does wait until the receiver replies. This is needed for example, when sync configuration is done. The engine needs to wait until the sync is ready, and the sync replies with an acknowledge. In this case, you can set a timeout, and you get the reply message, you get a reply signal, and for the receiver it's very simple. You have the message, just call a reply, and the message is sent back. And now we can look at the data, how the audio samples flow through the engine. ActiveAE uses a pre-allocated buffer pool for the various stages. So there's no further memory allocation after the engine is configured. I think the old soft AE worked on a per sample basis. So every sound sample was touched by the engine, which was not very efficient. We have sometimes seen CPU raises to 100%. It really touched every sample. Here the sound buffers are aligned to the buffer size of the thing. So it first configures the thing, and then depending on the buffer size, all the buffers or buffer pools of the various stages are created. First, when we get into the engine, we copy the sound samples we get from the players into a free buffer. At that point, currently, we get a float interleaved from the players. So with the last FFmpeg change, FFmpeg supports planar formats, and it's much better to keep the format we get from FFmpeg as long as we can. So that's room for future improvement. So don't convert the float interleaved, but leave it planar. Next stage is resampling stage, done by FFmpeg resampling library. So at that stage, we do resampling, down mixing, up mixing, convert forward to the format we use internally, which is float interleaved currently for all other than transcoding. So the engine is prepared to handle both formats, and when we're going to transcode to Dolby, the engine already uses internally a planar format because the encoder requires to get fed with planar. Then once it can handle different streams. So once the sample gone through the resampler, we are in the internal mixer stage. So FFmpeg can't do the mixing, so we have I kept the old way of doing this. The old audio, not old, still current audio agent provides functions for the mixer, the famous SSE stuff. And the mixer can mix various streams, and it mixes finally GUI sounds into the audio stream. And finally, we have to remap the channel layout to the actual channel layout of the thing. FFmpeg does not support applying a concrete channel map to the format. So you can't say, for example, back right or back left you won't have on channel 1 or 2. Because of this we have to have a separate stage here. I wondered whether audio APIs to provide functions of setting the desired channel layout. But currently, I think either has no means to set the channel layout. I'm not sure about Windows or the other platforms.
Also does have support, but it's only if the hardware supports it. Also, may have support for it in newer terminals, but many hardware doesn't support it. So.
So if it can be done directly, we can skip this stage here. And finally, we go to the output stage, and the buffer is handed off to the sink itself. If you go pass through, we have a stage here which requires no work. The buffer goes through with no work applied to the audio samples. And finally, when a buffer is returned, it flows back to its original buffer pool. So for pass-through audio, it flows directly through to the sink and gets back without any manipulation of the data being done. But I think, that's initial design. There's still lots of room for improvements in three-column performance, stability, I don't know. So I don't know. I have no plan for myself when this is or when this should be done, but maybe not too long after we released Gotham, that we continue improve things before nobody remembers how it was done. So keeping the planar formats, which was a big pain point after the last FFmpeg upgrade, it broke quite a lot. It keeps the format, do the final conversion to interleave at the sync stage, leave it to the sync, get it out of the audio engine. Remapping the sync layout might be much faster when we have planar format. It's just remapping a pointer. We have interleaved there, we have to touch every sample, which is quite some overhead. And I did not mention it in the slide here. Go back some slides. So the weak point, a pain point is here. In the first iteration, I did not touch the existing audio API, but it would be much nicer if the players could listen to events of the engine instead of polling it. But some state changes here, for example, a delay or is buffering or volume or whatever, audio engine just sends some message out to every client which has a connected port or hooked in by a callback or whatever. But the polling interface is really pain make the system brittle. This was the area where I fixed most of the bugs. And this not only applies to audio, there's many other parts in the current application which suffers from the same problem. For example, the UI, currently UI pulls everything out of player, of any component. And we currently have some problems with deadlock in PVR stuff. Because nobody knows when the graphics context block is taken, grabbed, and nobody knows.
That's not. I think that deadlock is not related. It's the pop-up that's deadlocking. I think that you mean that one. But I've already changed a lot of stuff in PVR to use messaging instead of polling. So I already did some work there, but there are still indeed, if you look at C application, there's a lot of polling all the time. We are polling every part of the system in each iteration of the loop, and it's stupid. Yeah. I definitely agree with that.
I think we can ship 2 or 3 or more releases without adding any new features, just to fix the stuff we already have.
And performance will improve dramatically.
What did you do for making the interface portable? Did you insert another layer which just keeps flags for your callbacks and so the player can call them, or did you integrate it into
I have a passive class which stores the state and which has a lock, and if the engine gets polled, it's just sends back the information from the passive class. Just like DVD player does the same thing with the state.
So, but your passive class implements the callback interface from activating gets callbacks on state changes, so it does it call too somehow? Or?
Yeah, the API is made for polling. So if player, for example, calls get delay or is buffering, it calls a method on active AE or active AE stream, and this method just calls another method on the internal state handler, which is a lock.
So it's completely around the callback system in that case.
Yeah, it violates the basic idea, yeah, but yeah, it's like this currently.
Okay.
Do you have any thoughts on how, the get delay functionality is always insanely tricky to get working. How we solve that now to maintain the delay state between these separate syncs and the other parts of the engine?
Well, the get delay was completely broken software, I think. Did not work. We had
got fixed, but now it was
needed many locks and got a weird way through the system. Yeah, it called the sync called back to the engine.
Yeah.
And what I currently do with Active AE, when a sample is handed off to the driver, it calls the get delay on the driver.
Yeah.
And update the state in a passive class. And it's active, and it also updates a timer. And if the player wants to know the get delay, there's a small calculation, the last delay plus the time difference between now and the last call. But ideally, it would be the engine would send the get delay of this information out to player.
Yeah, that's what I was thinking. Do you have any thoughts on how to solve this better? Because we're always going to have a situation where we need to do transcoding or just doing resampling, and that means we're going to have buffers flying in multiple levels in the software.
Yeah.
And how do we keep track of how it syncs so we always know when to put something in one end, when it's going to be out at the other end?
Yeah, it's still some old code in here. So when player wants to know the delay, the engine has to do some calculation. So it knows the actual delay on the thing, but you have to calculate the delay on the resampler plus the buffers, which is not ideal. So maybe it would be better if player just sends a sound packet in with a timestamp,
Yeah.
and the engines, when it outputs a sample, it sends back, okay, this timestamp is now audible.
Good plan. So then you can itself calculate the difference.
Yeah.
Yeah, that's probably a better idea.
Well, as said, there's enough room for improvement and enough work to keep not only one dev busy over the next month or year even.
So the soft AE code will stay for a bit longer now.
I thought I had a slide here.
That was
Maybe it's this one. Quick question again?
the soft AE part. Will we keep that still, or are we just?
Yeah,
dumping
it's still in the repo, but yeah, it depends on how much I need to change with the new audio settings page. Well, when the settings are going to be restructured, we have to touch the various engines we have.
it?
And I'm not sure if it makes sense to update soft on all these settings changes.
I don't even think you should update.
It's not actually being used now.
We don't even use it anymore.
Fridge announced, he said you should kick it out, soft AE.
Yeah, just dump it.
Just kick it out.
We don't use it.
Yeah, okay, then I can drop it with the next PR I do for the audio settings.
So drop it down.
And
Throw it out.
maybe one more thing. I do the audio settings page, and I can adapt active AE, but we have core and we have pulse. Who would take care for those engines to adapt to the new audio settings? Francis?
No deal.
Yeah, could you repeat your question? I was just chatting with Fridge.
Well,
He said yes, so he should be.
We are going to have the new audio settings page
Yeah.
next month for the next merge window. But I can't complete it myself. I can do the adaptation of active AE to the new settings, but I need help for the other engine. So you for core,
For core audio.
and who volunteers for pulse?
Is this what we're working on?
How is it actually used?
I don't know. But it will probably break if we change the settings.
But we need calls technically on any modern distro when we're running. We hijack Elsa. You know, it just doesn't work well.
Also uses, if you have pulse audio in but ALSA uses the
It goes through calls, but the Alsa, normally if you open Alsa on a modern distro, it'll go through calls.
yeah.
And that emulation is shitty, and just you don't want to use it. So then you want to do calls directly.
Yeah, but if you have the pulse audio engine which you have,
Yeah.
I'm not sure how usable it is currently.
Yeah.
It's able version.
Yeah, I don't think it's enabled at all.
A lot of problems.
Yeah, I can sort of.
Yeah, but I mean, we should still have a pulse sync.
Yeah. But yeah, I'm working on it.
Okay, all right. But I mean, if we have pulse sync for active AE, we can drop the pulse engine because obviously nobody's been interested enough to actually build a proper pulse engine.
Yeah.
So, I mean, the pulse engine is insanely simple compared to all the other engines. So, I mean, that just opens up streams. So, for any sound that's going to be played, it just opens up the pulse stream. It's done. So, it's not really any complexity in it. But, I mean, as long as we get a pulse sync for active AE, I mean, there's no major reason for us to keep the other one. We still need the sync for it.
Yeah, that's for sure, but I don't think we get the thing for the next merge window. So we need someone to look at the pulse engine when we have the change in settings.
It's compiled though. It's a compiled switch for pulse.
Yeah,
That's an
it should,
enable clause, so it's
should
fine.
be
if it
allowed
breaks.
either way.
If it breaks, that's fine.
Yeah.
Okay.
Right, so as long as it compiles, is it?
As long as it compiles when it's disabled.
Right. Okay.
So you don't see.
And it's disabled by default,
I think it's disabled by default.
I think it's auto select, so you don't have to worry about it.
Yeah. Shouldn't go in whatever.
Did you get a pull request up for the auto settings page already, or is it still in the forum?
Yeah, started work last week, so
Okay.
it's going to take me a while to get ready for the next window.
So should I wait until you do a pull request?
Well, I can contact you or drop your mail once I have something worth looking at it.
Yeah.
Well, it shouldn't be done before next window. Next window, it's mandatory for Gotham, so should go in whatever in the merge window.
You have to do some testing.
If it's not the next window, it will be the next window.
It might be that I'm not around in the next window. Going to Shanghai, but I try to do something.
No, that's wrong. You won't go away.
Well, there's one question I can't design by my own. I have started to work on the audio settings, and it would break settings backwards compatibility. So are you fine with that? Or do you want to keep it inside the code, or we provide a kind of migration script for the settings once users migrate from folder to Gotham?
Can you try to use the update functionality that I implemented?
Yeah, I
You
looked
can
at it,
rename
but
settings,
Yeah, that's
change their value.
That's kind of messy in the code, and you don't know what setting is really used and what is the old settings, what's renamed. So
Can we just
I
load them
would
and save?
prefer keeping that out and provide some kind of migration for the users.
I would say go save with the settings. Default to save. And audio files want you tweak it anyway, so.
I mean,
Yeah.
what's the chance of someone updating and there being no audio at all for them? Because what it will do is it'll just, because you're going to add new settings, right? You're not going to
You
repurpose the
should
current
change
ones.
the.
Yeah, I am going to create new ones, rename old ones, or drop old ones.
Yeah.
And-
So just go.
Right, so they're going to be brand new settings essentially, so they'll have no default value at all. Well, you know, they'll take the default value that you specify for them.
Which
Yeah.
should be saved.
But we not going to change behavior, so there would be a migration path, transform the old settings to the new settings.
How much sure are you that the old settings are correct?
Yeah, I don't know, that would be, I don't know if it's worth.
Maybe the migration will
I don't know if it's
worsen
worth
the
it.
situation.
I would keen to do the new settings
So-
and get the defaults,
Okay.
you know.
So
okay.
basic audio should work,
Exactly.
but if a user has fancy settings, you have to touch.
You have to just reset them again. I mean, it doesn't take a user long. So.
Yeah, it's maybe 10,000 users who would complain out of the 3 million.
And that's what happened with here. Yeah. I mean, we'll just. No one's going to care. No one's going to care. Thank you.
And
Thank you.
Thank you.